In this video we're going to learn how to calculate the gradient of a curve at a given point. So if we start with a function like this, so f of x is x to the power of 4 minus x cubed plus 3x, then this is our function. So this is called a function. And like we've been doing before, we're going to differentiate it, and that gives us f prime of x. And differentiating this is going to give us 4x cubed minus 3x squared plus 3. And this is called our gradient function. So we've got our function and our gradient function. And this gradient function looks quite abstract, but it's actually very useful because we can use it to calculate something specific, which is the gradient of the curve at a given point. So for example, at the point x equals 1, we can write f prime of 1. That means that x equals 1, and we're calculating the gradient function at this point. All we have to do is substitute 1 for x. So every time we see an x, we're going to put 1 instead. So we've got 4 times 1 cubed minus 3 times 1 squared plus 3. And we can calculate this bit because 1 cubed is just 1. So we've got 4 minus 3 plus 3. And that's just equal to 4. Which means that the gradient when x equals 1 of this function is 4. So let's do another one. So f prime of 2, what that means is that we're going to calculate the gradient when x equals 2. So in the same way, we're just going to write 2 instead of x. So we've got 4 times 2 cubed minus 3 times 2 squared plus 3. And 2 cubed is the same as 8, so that's the same as 4 times 8 minus 3 times 2 squared, which is 4, plus 3. And we can calculate these bits. So 4 times 8 is 32, 3 times 4 is 12, and plus 3 at the end. And this is equal to 23. So we have an answer for what the gradient is when x equals 1 and what the gradient is when x equals 2. But we could have actually done both of these just using a graphical calculator. So I'm going to bring up my calculator and I'm going to type in the equation that we got. So we got x cubed, x to the power of 4 minus x cubed, and then plus 3x. Okay, and let's draw the graph for that. Alright, so this is what the graph looks like. And to find the gradient at these points, we do second and then calc or trace. And if you look on this list, number 6 says dy by dx. So if I press 6, that takes me straight to finding the gradient. And the point that we're interested in is when x equals 1. So all I do is type in 1, press enter, and wait a bit, and you get that dy by dx at this point is 4.00003. This is just an approximation, and in fact we can compare this to the 4 that we got, and we see that the answer is actually 4. So we can use this either to check our answer. In this case we have calculated it, so we can use this to check our answer, or you can use it to calculate it if you don't want to do it by hand. And if you get a number like 4.00003, you would just say that the gradient at this point is 4. And let's do the same for the second one. So we've got the same graph, and we go second, calc, and then press 6 to get the dy by dx. And now we're interested in the gradient when x equals 2. So I'll type in 2 and press enter, and it tells us that dy by dx is equal to 23, which is what we got in the question. So we've used the calculator to check our answers to both of the questions, and it shows that we get the same answer, so that's promising. And in the next video we're going to do a couple more examples of this.